When current flows through a wire, a magnetic field is produced. A magnetic field is also produced when two bar magnets interact. If a wire is placed inside this magnetic field, the magnetic fields of the magnets and the wire interact, and the wire experiences a force. For a wire which is at right angles to the direction of the magnetic field, we can determine the direction of the force using Fleming's left-hand rule. Make this shape with your hand, with your index finger pointing straight out, your middle finger pointing at a right angle to your index finger, and your thumb pointing straight upwards. If you line up your middle finger with the direction of the current, and your index finger with the direction of the magnetic field, the direction of your thumb will tell you the direction of the force experienced by the wire. This also tells us the direction the wire will move. For this wire, at right angles to the magnetic field created by these two bar magnets, the direction of current is out into the screen, the direction of the field is to the right, so the direction of the force has to be straight upwards. We can calculate the force experienced by a wire, assuming it's at right angles to the magnetic field, using this equation. Force is equal to magnetic flux density, which determines the strength of the magnetic field, times by the current flowing through the wire, times by its length. The stronger the magnetic field, the higher the current, or the longer the wire, the greater the force experienced by the wire. Force is measured in newtons, magnetic flux density is measured in Tesla, current is measured in amps, and length is measured in meters. For example, a 2 amp current flows through a 5 centimeter wire placed between two magnets at right angles to the magnetic field. The magnetic flux density is 0.04 Tesla. Calculate the force exerted on the wire. Force is equal to magnetic flux density times current times length. That means the force is equal to 0.04 for magnetic flux density times current, which is 2 amps, times the length of the wire, which is 0.05 meters. Length has to be in meters, so we need to convert it from centimeters. 0.04 times 2 times 0.05 is 0.004 newtons, so the wire experiences a force of 0.004 newtons. Here are some practice questions for you to try. Pause the video and give them a go. The equation for calculating the force experienced by a wire is force in newtons is equal to magnetic flux density in Tesla times current in amps times length in meters. In the first diagram showing Fleming's left-hand rule, current points in the direction of the middle finger, magnetic field points in the direction of the index finger, and force points in the direction of the thumb. In the second diagram, if we use Fleming's left-hand rule to line up the directions of the current and magnetic field, the direction of the force will be straight out towards us, into the plane of the screen or the paper. If you imagine you're looking down on these magnets and the wire on a desk, then the force would be acting upwards towards you. For the wire in question 4, we use the equation from the first question. Force is equal to magnetic flux density of 0.03 times current of 5 amps times the length of 0.1 meters. We have to convert the 10 centimeters into meters. That gives us a force of 0.015 newtons.